morning, my YouTube viewers. It is Crystal here. I'm just here because I wanted to give you another code review. I'm giving you the code review on a community competition called Data Science Capstone Project 2023. I'm not sure exactly what a capstone project is. I think it's, let's look it up and see what it says. Capstone. A high point, crowning achievement, the capstone of her career. So that's what this project is, and it's on Air BnB. And so basically what we're going to do is we're going to go through the code review on it. I worked on it last night and a little bit this morning to improve my score. But since this is a past competition, I don't actually show up on the leaderboard. So what we're going to do now is I'm going to take the link to the notebook and I'm going to put it in the description box down below so you can look at the notebook if you want to. But it has to do with Air BnB. And so there were people who scored better than me, but they didn't make their code available. And since they didn't make their code available, I don't know what they did to score better than me. Because generally, people who win competitions, they don't make their code available to other people. So you just have to guess. You just have to do your best. And really what you want to do if you want to win a competition, you have to pick a competition that has at least 1 month to go. And then you have to go through and look at everybody else's code and see what they did to have a high score and try to replicate what they did. But I don't do it that way because I like to make my code in a very methodical manner. So what we're going to do is we're going to go through my methodical notebook and we're going to review it. And just this morning before I did the code review, I actually made some changes. And since I made some changes, I improved my score by about 4 points. So this is for the capstone. This is for the Data Science Capstone Project 2023, and my best score was 61.47. Context. Since 2008, guests and hosts have used Airbnb to expand on traveling possibilities and present a more unique, personalized way of experiencing the world. This dataset describes the listing activity and metrics in New York City, New York for 2019. The context. This data file includes all needed information to find out more about host, geographical availability, and necessary metrics to make predictions and draw conclusions. Inspiration. What can we learn about different hosts and areas? What can we learn from predictions? Example, locations, prices, reviews, etc. Which hosts are the busiest and why? Is there any noticeable difference in traffic among different areas, and what could be the reason for it? How does proximity to different points of interest impact prices? And then the task is to predict the prices of Airbnb listings. So the first thing we want to do is we want to import the libraries that we are going to use initially. So that's going to be NumPy as NP. So that's going to create your NumPy arrays and perform numerical computations. We're going to import pandas as PD. So that is to create series and data frames and also perform data processing. We're going to import OS, so that's going to go into your operating system. We're going to import matplotlib.pyplot as PLT, so that's going to visualize your data. and we're going to import Seaborn as SNS. That's also going to visualize your data statistically. Then what we're going to do is we're going to get the files, and we're going to use OS to get the files. So when we get the files, we've got 3 files, which is train, test, and sample submission. Then after we've obtained the files, what we're going to do is we're going to read the files. We're going to use pandas to read the files and convert them to data frames. So it's going to be train, test, and submission. So we look at train. You can see train here. And you got 39,118 rows by 17 columns of data. We're going to describe train, and what it's going to do is it's going to describe all of the numerical columns. It's not going to describe the object columns. If you wanted it to describe the object columns, I think in here you would say equal all, and it would describe all of the columns. We're going to do train info, so that tells you information about the data frame. It tells you that you've got a combination of integers, objects, and floats. So what is going to happen is the computer won't be able to make predictions on objects. So since that is the case, that at some point we're going to have to take the objects and we're going to have to convert them to integers. So right off the bat, I want to delete a few columns of data, and the reason why is you don't need it. You don't need ID, and the reason why you don't need ID is because every every row is indexed, so you don't need ID. You don't need host ID, you don't need name, and you don't need host name, because every row is indexed. So what we're going to do is we're going to take the last review and we're going to use pandas to timestamp it and convert it to date time. And then we've got up-to-date review is going to be a blank array. And date 2019 is going to be PD to date time 2019-01-1. Then I'm going to make a for loop. And so if the date of last review is greater than or equal to 2019, it's 1. Otherwise, it's 0. And we're going to append that to up-to-date review. We're going to print the length of the up-to-date review, which is 39,118. We're going to make a new column in train called up-to-date review, and we're going to put up-to-date review in it, and then we're going to have our train column with our up-to-date review at the very end. So you can see that this is up-to-date review, so it's going to be either a 0 or a 1. So now what we're going to do is we're going to delete the last review because that's not necessary anymore. Because the up-to-date review is going to be 0 or 1. Now we're going to check for null values, and we've got null values in reviews per month. So what we're going to do is we're going to drop all of the null values, because the thing is that if the data frame has null values in it, it's going to be difficult to make predictions on it, and you could impute it with mean, median, or mode, or anything else, but I just decided just to drop it. So we're going to drop everything with a null value. And then what we're going to do is we're going to do a little bit of feature transformation, where train reviews per month equals train reviews per month dot as type int. Train noise dB equals train noise dB equals as type int. So we're going to convert these floats to integers, so it will be easier for the model to be able to make predictions if they're integers instead of floats. And then so now what we're going to do is we're going to find all of the unique values or the number of unique values in the data frame. So neighborhood group has 5 unique values. Room type has 3 unique values. Floor has 12 unique values. Up-to-date review has 2 unique values. Now we're going to look at test. Test is the same as train except for the fact that it does not have price in it. So we deleted the same rows in test that we deleted in train. We manipulated the last review and up-to-date review in the same way that we manipulated it in train. So we deleted the last review, and what we're going to do is you can't delete the rows that are null in train because it won't work when you try to submit it to Kaggle for prediction. So we're going to take the null values of reviews per month and we're going to replace it with the mean of that column. And so now we check for null values and there's no null values. And now we're going to take the reviews per month and the noise, we're going to convert those to end. And now we've got submission. So now what we're going to do is we're going to analyze the train. So we look at the price. The price is a regression. So that tells you what the price is. We put it on a counter. We do train price value counts. So you see that you've got quite a few ones in here. And the model is not going to be able to predict on a target value if there's only one of those target values. You need at least 2. So what we do is we filter out all the target values that you have greater than 1. So now we've got 31,021 rows and 13 columns after we have filtered out all the target values that are greater than 1. So now we do a pie chart on room type. You can see there's 3 different types of room: a private room, a shared room, and an entire apartment. We do another pie chart on the neighborhood group. So you see you've got Brooklyn, Manhattan, Staten Island, Bronx, and Queens. Now we do a bar chart on up-to-date review, and so there's only 2 values. This is a binary, so it's either 0 or 1. So you have more 1s than you do 0s. And now we do a box plot on neighborhood group, so you can compare the neighborhood group to the price. So Brooklyn and Manhattan are very similar, and then Queens and Staten Island and Bronx are the last 3. Now what we do is we do a plot of the map. I really like that. So this is a map of your longitude and latitude. So that looks like New York City, I suppose. Now we're going to ordinal encode all of the object columns in both train and test. And now we're going to create a heat map of train. And so you can see that number of reviews and reviews per month have a pretty good size correlation. But even though they have a high correlation, a good size correlation, I'm not going to delete any rows because there's not any columns because there's not that many columns anyway. Now what we're going to do is we're going to take our data frame and we're going to convert it to X and Y variables, which is our independent and dependent variables. So in Y, you take train and you pop the price out, and then X is train after you pop the price out. So you can see in train, in X, you got 12 columns, and in Y you've only got one column. So now what we're going to do is we're going to use sklearn to convert the X and Y data set, X and Y variables, to training and validating data sets. And then you check the shape of those as well. So now we look at xtrain, and you can see what xtrain is. You can see it's all floats and integers, so that's what we want to see. Now we've got into TensorFlow, and when you get into TensorFlow, we want to go ahead and import the libraries and modules associated with TensorFlow. We're on version 2.11 in Kaggle's Jupyter Notebook. Now what we want to do is we want to standardize the data. So we're going to create our first row of the model. Normalizer equals normalization, axis equals -1, normalizer.adapt, np.array xtrain, print normalizer.mean.numpy. So it's going to print the mean of the normalized values into a numpy array. And so now you can see what the value is when it hasn't been normalized and what the value is when it has been normalized. And now we're going to create a deep neural network. It's going to be a sequential deep neural network. We're going to call it Air BnB. So the first row of the deep neural network, or DNN, is the normalizer row where the data is normalized. And then the second row is dense, 100 neurons. Input dimension is x.shape1. Activation is ReLU. Name is hidden1. And then we're going to add another layer. Model.add. Dense is 100 neurons. Activation is ReLU. And name is hidden2. Then we're going to add a third layer, or a fourth layer. Model equals dense 1. 1 is because you've got one output. Activation is linear, and name is output, and then we summarize it. So you can see you've got normalization, hidden1, hidden2, and then output. Now what we're going to do is we're going to compile the data. The optimizer is going to be RMS prop. Loss is going to be MSE, and metrics is going to be MAE. We're going to set up early stopping and model checkpoint, and then we're going to train the data. So history equals model.fit, xtrain, ytrain, batch equals 32, epochs equals 100, validation data equals xval, yval, callbacks equals early stopping and MC. So we keep going down here, so it trains the model. It is going to early stop. It's not going to train it for a whole 500. It is going to stop early. So it stopped at 244, and now we evaluate the model. We have an MAE of 3627. So now what we do is we're going to plot a graph of the loss and the error. So the loss and the valve loss are pretty close, and the MAE and valve MAE are pretty much the same. We're going to predict on the validation set, and you can see that we have an MAE of 36. And then we plot a graph of the actual values as opposed to the predicted values. And so it's pretty close. It's pretty close. It's almost right there on the line. And now we create a data frame of the actual values as opposed to the predicted values, so you can see how they compare. Now we're going to predict on the test set. Just want to check something. Okay. I didn't do the abs. On the test set, we had some negative values. And because we had negative values on the test set, I said prediction equals absolute value of prediction. And then I rounded it to one value, and then I flattened it. But we don't know what the MAE was until we submit it. And then we prepare our submission. So submission price equals prediction. Submission to CSV is submission.csv, index equals false. Submission equals PD read CSV, submission CSV, and then there's your submission. And so this is what we saved it, and we submitted it to Kaggle for scoring, and I got a 61 when I submitted it to Kaggle for scoring. But unfortunately, I couldn't get on the leaderboard because this competition has already passed. And since this competition has already passed, I'm not on the leaderboard. But I wanted to do the competition anyway. And while I'm entering competitions, what I want to do is enter past competitions, because I'm living in the UK, so I can't collect a prize because you have to be in the US to collect a prize. And when I get my level of expertise approves enough where I can collect a prize, I'll get my passport for America, and then I can go to America and collect a prize if ever I'm going to win one. So that's it for this code review. I'm going to have to go ahead and let you go because it's almost time for me to leave for my day job. And thank you so much for watching my code review. If you like my code review, please like, subscribe, and share. If you want to be notified whenever I make a new code review, then please tap onto the bell button next to the subscribe button. So thank you again for watching my code review. I look forward to communicating with you in the next video that I make.